Okay, lesson 3.1, we're going to identify pairs of lines and angles, angle pairs that are formed by three intersecting lines. First thing we need to do is look at two lines that do not intersect are either parallel or skew. And parallel lines are coplanar, but skew lines are not coplanar. Two planes that do not intersect are called parallel planes. So let's look at the diagram. Lines M and N would be parallel, but M and K would be skew. Planes T and U are parallel, and lines K and N are intersecting. Okay? The two lines side by side means is parallel to. So let's look at some relationships in space, looking at this box. And you have to think of each segment as if it were an extension. Okay? So I'm just going to kind of draw a few on here to show you. Okay, they're actually, the figure is just parts of lines. So which line or plane in the figure appear to fit the description? So let's look at the first one. Lines parallel to CD. Lines parallel to CD. So first thing I'm going to do is highlight CD. Oh, trying to make the thickness less. Okay, so CD is here. So what would be parallel to that? Parallel would be AB. Oh, and it says end containing point A. So parallel and containing point A. We're looking at point A. The only thing parallel to that would be line AB. Line skew to CD. Containing point A. So skew to CD containing point A would be line AH. Lines perpendicular to CD containing point A. Okay, you can see the little perpendicular marking there. So that would be AD. And a plane parallel to plane EFG. Okay, so EFG is this plane on the bottom. Let's see if I can make that darker. Make it purple and that might show up better. Yeah. So EFG is here on the bottom. I made it a little bit darker. And I need a plane parallel to that containing point A. So that would be the top plane. So it would be plane, and you can name it any three letters. I'm going to call it ABC. Okay. Now we're going to move on to two lines in the same plane are either parallel or intersect at a point. So through a point not on a line, there are infinitely many lines. Exactly one of these is parallel to the given line, and exactly one is perpendicular to the given line. So we have these two postulates here. So if we have this point P, there's that point P. There's only exactly one line that I can draw through P that would be parallel to L. And the same thing with perpendicular. There's only one line that I can draw through that point P that would be perpendicular to L. Okay, it's going to probably be a little tricky to see, but we're going to look at this diagram and try to highlight these yellows a little bit better. And I'm going to turn, make sure you can tell that this is perpendicular here. Okay, these are your parallel markings there. Alright, so let's look at given line markings show how the roads are related to one another. Name a pair of parallel lines. So I have AB is parallel to EF. A pair of perpendicular lines would be BF. It's perpendicular to, oh, this should be MB. I'm sorry, I know I wrote that wrong up there. A is over here. So this up here, apologize for that, should be MB. Couldn't tell that A was on that other line. Is FE, let's see where FE is it parallel to AC? And that would be no. You have FE parallel to MD, and only one line is parallel that contains point M. Okay, so you have some practice, couple problems on the next page. Make sure you pause the video before trying them, and then come back and check your answers. Okay, hopefully you did well with those. And we're going to look at two lines and this thing called a transversal. A transversal is a line that intersects two or more coplanar lines at different points. So the first one, looking at corresponding angles, they're in the same position. same position. So in this first one, you have 2 and 6, they're both above the line and to the right of transversal. Okay, there would be 7 other pairs of corresponding angles with 2 intersecting lines. And we'll identify them in one of our examples. Okay, alternate interior. So think of between the 2 lines as the interior. So this is the interior. And alternate means opposite. Alternate exterior, so think of above and below, wherever the 2 lines are, as the exterior. And then consecutive interior, think of them as being on the same side, and in the inside. Okay, as you can see that they're sometimes called that, but you will only see them being called consecutive interior angles in this book. So we're going to identify all pairs of angles of the given type. I'm going to label or highlight the interior, purple, and the exterior, yellow, because this is on its side from the earlier diagrams. So corresponding, same position, 1 and 5, 2 and 6, 3 and 7, 4 and 8. 4 pairs. Alternate interior, 2 and 7, 4 and 5. 2 pairs. Alternate exterior, 1 and 8, 3 and 6. 2 pairs. And there'll be 2 pairs of consecutive interiors. Same side. Think same side. Inside. 2 and 5, 4 and 7. Okay? So now you have a few to try on your own. Naming. Basically naming what pairs of angles we have. Pause the video and then push play when you're ready to check your answers. Hopefully you got those answers. And we're going to close the lesson with what angle pairs are formed by transversals, corresponding, alternate interior, alternate exterior, and consecutive interior. Okay, make sure you submit your notes in the proper assignment.